Do you remember this graph from grade 11? 1 over x squared graph? Did you give it a name? It's not an official name of this graph, but did you call this graph something? Do you remember? Sometimes teachers call this one the volcano graph. Does that ring a bell? No? Because it kind of looks like a volcano. I mean, and it's got like this asymptote here, which is like spewing asymptotic lava everywhere, maybe. Use your imagination. No? That's our 1 over x squared graph. So what we want to do is we want to, big key word here, describe how the graph could have been translated to create each of the graphs below. Now, I'm highlighting the word describe because there are 2 words on the final exam. They actually put this on your formula sheet. They have a number of keywords that they define. Describe and explain are 2 of those key words. And they want you to use words only, sentences, when answering the question. So there was a question on the exam in June where the answer was written the wrong way. The answer was written like this, and it should have been written like this. And the question said, describe Tim's error when he wrote his answer. And a lot of students just wrote the right answer, and they get 0. If it's a describe question and you do not use words, they'll give you 0 marks. Even if they, like, the student that wrote this knew the right way to write the answer. They knew what was going on, but they didn't know the command word and what it meant. So they knew the math, they just didn't know how to follow instructions. So we're going to really pay attention to that throughout the year. So describe or explain means you have to use words. And they tell us when they train people to mark the exam, they say if the student has math, put your hand over top of the math, just read the words. If the words don't make sense without that math, then you can't give them marks for that. It has to make sense completely from the words alone. Now this one's not a very hard one to describe, right? First of all, I would probably take this equation just because I like to write the y by itself and move that 3 over to write 1 over x squared plus 3. And then I start my words. The graph has been vertically translated. Now, here, if you use the number 3, they're not going to say, oh, that's not a word. That'll be fine in a sentence because you're using a sentence. The graph has been vertically translated 3 units up. So I'm trying to use all the correct terminology in here. Someone in the other class said, if I didn't write vertically, would I still get it right? Well, the question that has to be asked is it still clear what you meant? So if I take out the word vertically, and it says has been translated 3 units up, is that clear? Yes. It's still telling you which way it's going, right? It's not like up can't be horizontal. So then I said, yes, that would still be considered correct. You know, if you had a different word like shifted instead of translated, they would accept that, right? One exam, we accepted shifted, and it's hilarious. The student forgot the F. It was an accident, but we still gave them full marks. Okay? But if you forgot the word up, all of a sudden it's not clear anymore. So those are the kinds of things that we're looking for clarity. This question also says, what are the equations of the asymptotes in your image graph? Well, I'm going to label my asymptotes here in green. That vertical asymptote is x equals 0. This horizontal asymptote is y equals 0. Imagine those 2 dotted lines. If you move the graph 3 units up, which one's going to change? the horizontal one or the vertical one? Right? So here you can even imagine I'll just take those dotted lines. If I move that one up, does that change? Or is it still at x equals 0? Still at x equals 0. If I take this one and move it up 3, does it change? Yes, it does. So what are our new asymptotes? We'll still have x equals 0, but our new asymptote will be at y equals 3. For part B, again, I'm going to just rewrite it. Compared to our original 1 over x squared graph, we now have an x plus 3 on the bottom. We now have a minus 4 afterwards. So the graph has been horizontally translated three units left, and vertically translated 4 units down. If we think of our asymptotes, the vertical asymptote at x equals 0, it's going to get moved 3 units left. So it's going to become x equals negative 3. Our original horizontal asymptote at y equals 0, it's only going to get changed when you move things up and down. It's moving down 4. So it's going to become y equals negative 4. Questions for practice on this one are 16